Hello everyone, wishing you all a very good afternoon and welcome to this class for Crash Course in Physics. I think today is lecture number 14th or 15th, I guess. 14th. And we have covered up almost I should say 2/3 of the curriculum for the standard 11th. We're almost done with your mechanics. The only thing that remains is gravitation and fluids in mechanics. Gravitation we'll do after electro. We'll start electro from the next day. And then we'll be starting with your 12th standard curriculum. Am I audible and visible to all of you? Can you all see me? Can I have a wave hand that we understand you, sir? That you are audible and visible? Okay, great. Now, we'll definitely wind up SHM in this class. We'll be solving some questions on SHM. This is one chapter from where I expect that you might be getting a question this year. And again, that question would be simple to do. As we have seen the examples in the previous class, that most of the questions that come from this chapter are simple ones based on simple concept. Most of them are based on these graphs. We have discussed all these graphs in yesterday's class. In today's class, we'll try to wrap it up with the small things that you must remember. I think we finished yesterday's class with simple pendulum ka time period in a accelerated difference frame. That was what we did, and I told you that wherever you have G appearing in any equation, and then you are in an accelerated frame, this G gets replaced by G effective. Now, how do you find the value of this G effective? Well, you just add this original G with the acceleration of the frame of reference. In fact, if you are in a non-inertial reference frame, you'll have to add the negative of this. So you see, that's why this negative sign comes. I hope you will be able to understand this. If I do it with a question, and this question has come in various forms, in various ways, so we can solve this question and understand how this G comes into the picture, how this G becomes a G effective. So I have a simple pendulum. It's suspended from the ceiling of a car, accelerating uniformly on a horizontal road. If the acceleration is A naught and the length of the pendulum is L, find the time period of small oscillation about the mean position. Try to understand here that the mean position of this pendulum has also changed. That is one thing that we'll look into it. Where is the mean position? You can see here, this is the original mean position. This is the original mean position, which is vertical. But when this car is accelerating, and it is accelerating like this with an acceleration A naught, its mean position also changes. Its time period also changes. You have to find out what is the new mean position, which is not asked in the question, but I am asking you, what is the new mean position and what is the time period of oscillation? Now, this question could be asked in this way: what is the difference in the time period between this thing and that thing? So then you will have to go into that error wala question that I already told you. So they can mix up these two topics and can give you a question. The most difficult questions that are there in JEE Advanced are always on this mixed topic. What do you mean by mixed topics? They mix things from one topic to other topic. They mix. For example, in electric current, in EMI, you will have questions where the particle will be moving, this rod will be moving, then this is a question of EMI as well as a question of motion in a straight line. So when these questions they get mixed, when two topics get mixed, then you have a question that is going to trouble you. Motion of a particle in a magnetic field, motion of a particle in electric field. You have to understand the concept of electric field, magnetic field, motion of a charged particle. When there is a current in the wire, how does this particle move? So you have magnetic field and motion coming into the picture, and that is where things get difficult. You have fluid, you have a question of fluid, and then you keep a particle and you try to understand the SHM of this particle. There was a very clear question that came in the 1970s where they had this U-shaped limb, and this U-shaped limb was kept in a different orientation, and then they started to move it, and then the liquid oscillates. You have to find the time period of oscillation of that liquid. Tough questions are made by mixing topics, and here we have mixed topics. We have mixed sometimes gravitation and SHM and errors, so it becomes a difficult question. Has anyone got an answer for this one? Where does the equilibrium position lie, and what is the new value of time period? Anyone? Any answer? Manoj, Ashrit, Vishnu, do you have any idea how to do this? So basically, you'll have to work in this accelerated frame of reference. That is the easiest way to understand this problem. Now, once you go into the accelerated frame, you'll have to apply your pseudo force on this body, and the value of that pseudo force will be m into a naught, which is like here, m a naught, and the value of this is mg, and this is the tension T. So it will be in equilibrium under these three forces. You can very well find the value of this theta naught from Lami's theorem or anything. You can easily calculate the value of this theta naught. These three forces are in equilibrium. T sine theta will become equal to T sine theta naught will become equal to m a naught, and T cos theta naught will become equal to mg. So you divide those things, so you will get tan of theta naught, which is the new equilibrium position, will be a naught by g. Do we understand this? This is the new equilibrium position. What is the new time period? See, they have calculated this time period using the initial principle, finding out the net torque and this and that. At the end of the day, they end up with this, and this is the basically value of G effective. What is G effective? Mg is going downwards, and this Ma is going here. So the vector addition of this mg naught and Ma naught gives you the effective value of G, and that is how you are going to solve this question. Do we understand this? Can I have reason that we understand this, sir? Whenever this vehicle is accelerating in the horizontal direction, the equilibrium position also changes. So now, if I go back, I just feel that you might get a question here. So if I go back and if I just make different cases here, case number 1 is acceleration is upwards or acceleration is downwards. In that case, your mean position remains same. And your time period becomes 2 pi root over L upon G plus or minus A. It will be plus A if it is upwards. If it is minus A, it will when it is downwards. Do we understand this? Raise hands will give me more confidence. Upwards, downwards, this is the formula. Now, if this is rightwards or leftwards, then the mean position changes, and the new mean position becomes tan of theta naught will be equal to A by G. A by G, and in this case your new time period will become 2 pi root over L upon root over G square plus A square. Do we understand this? Do we understand this? Can I have raised hand that we understand this, sir? No. I can mix these two. I can mix these two cases. I can mix these two cases. Please remember my words. I can mix these two cases, and then I can have a case where acceleration is like this. It makes an angle theta with the horizontal, and your acceleration due to gravity is always like this. So now I'm thinking about a case where I'm applying a pseudo force like this. I'm applying a pseudo force like this. That means the body is accelerated like this with an acceleration A. What will be the answer in this case? What will be the answer? If you apply some common sense, you should get me the answer. If you apply some common sense, you should get me the answer. So basically what I'm saying is your MA is like this and your MG is like this. Your mass into acceleration is like this. Remember, mass into acceleration and acceleration are two different things. For example, if the lift is moving downwards, if the acceleration of the lift is downwards, you apply pseudo force upwards. And then it becomes G minus A. If your lift is moving upwards, you apply pseudo force downwards. And that in that case, it is G plus A. Do you understand what I'm saying? So what I have drawn here is the direction of the pseudo force. What I have drawn here is the direction of the pseudo force. This is the direction of the pseudo force. So in which direction is the body moving? In which direction is the body accelerating? The body would be accelerating in this direction. Do we understand this? Do we understand this? Now what will be the answer in this case? What will be the equilibrium position? Okay, I don't have that much time that I can give. So what I'm going to do is, I'm going to break this MA into two components. This will be MA sine theta, and this would be MA cos theta. Now effectively what I have, please mark my words. Now effectively what I have is downward acceleration is G minus A sine theta. Downward acceleration is G minus A sine theta, and sideways acceleration is A cos theta. Is everyone there with me? Is everyone there with me? Can you tell me what will be the new mean position? Can you tell me what will be the new mean position? And maybe if you're lucky, you'll just get this same question in the examination hall. What will be the new mean position? Anyone? Remember, I have drawn the diagram of the pseudo force, not the acceleration. Acceleration is in the other direction. The new mean position would be A cos theta upon G minus A sine. When I have some raised hand, this raised hand is going to give me a lot of confidence that we have understood this. This will be the new mean position. Do we understand this? See what I have done here. This A was the horizontal acceleration. Now it has been replaced by A cos theta. This G was sort of the vertical acceleration, which is now replaced by G minus A sine. Now, if you have understood this, please tell me, what will be the time period of this? What will be the time period of this? 2 pi is there already. Root over L is there already. What will be coming in the denominator? I'm looking for the answer of the denominator only. I'm looking for the answer of the denominator only.
Sir,
Yes.
hello.
Yes, tell me.
G minus A sin theta whole square plus A cos theta whole square.
Yes. Well done. So you understand the concept behind it, beta?
Yes, sir. Yes,
G
sir.
minus A sin theta whole square plus A cos
Cos.
theta whole square. It cannot be whole square. It has to
And
be the root of all this.
yes,
You understand this? This is the
yes,
most difficult question that can be made, and if you're lucky, you will just get this, and probably you will then remember me that we have already done. Now, a question of this nature has already, I think, appeared sometimes, and it was just like this. Uh, the same question has this variation here, where you have this smooth inclined plane, and this truck or this box is accelerating freely on this smooth inclined plane. Remember, that means if it is moving here with an acceleration of a sine theta, we understand this now. Acceleration of any block down the plane will be a sine theta. So it is basically moving in this direction with an acceleration of a sine theta. You apply the logic that I've given you. Don't need to apply it here. Just remember that effective G becomes here G cos theta. Just remember this point, because this will save you a lot of time in the main examination hall. The same question could be asked in a different way. Instead of having a simple pendulum here, you could have water here, and this is a vessel filled with water and it is moving down. At what angle will the water be inclined, or what will be the effective gravity? Here also the equilibrium position changes of this simple pendulum. The equilibrium position changes, and the new equilibrium position will be same as this angle theta. Remember that. And how did we get this? No rocket science here. We had done what was supposed to be done. The only thing that changes, I gave you A in this direction, MA in this direction. This is A sine theta in this direction. If you put it in that equation, you will get the same result. Don't worry. So we got this. So you can apply this here, or you can apply it elsewhere. See, this is the formula that they have created. G effective is magnitude of G plus F by M. So I told you acceleration. Now instead of acceleration, you could have applied electrostatic force QE and mg. Are you getting my point? So these questions are all similar, beta. Nothing changes here. You just add these forces vectorly. This QE or this QE could have been like this also. QE. This QE could have been like this also at an angle theta. Don't need to worry. Find out the acceleration, divide it by the mass, and you have the effective value of G due to gravity. If you want to find out the equilibrium angle, divide the horizontal by the vertical. If you want to find out the time period, T equal to 2 pi root over G effective, the magnitude of G effective will be under root of X component ka square plus Y component ka square. Do we understand this? See, a very simple example is given here. A simple pendulum of length L and having bob of mass M is doing angular SHM inside water. A constant buoyant force equal to half of the bob is acting on the ball. So it is acting in the upward direction. It's constant buoyant force. So you just find out the value of G effective. G effective becomes G by 2, and you have the time period of this block as T pi 2 pi root over L divided by G by 2. It becomes 2L by G ka root. Do you understand this? Can I have some reason that you understand this, sir? No one understands. Manoj understood this. Bhojraju, Ashrit, Vishnu, all these small things will get you probably 4 or maybe 8 marks, and then your rank will drastically change. That is all I can do at this point in time, beta, because you can see the time that we have is very limited. Compound pendulum or physical pendulum. Now, instead of a blob, a small bob, you have a rigid body attached to it. So, how do you get it? To cut things short, you will have a time period like this. I hope you know this. Time period is 2 pi root over ICM plus ML square divided by MGL. What they have done here is, I hope you know this, na? It is not hanging from its center of mass. The center of mass is somewhere here. The center of mass is going to create torque. That center of mass ka torque will be mg into x, distance of center of mass into cos theta, sin theta, something of that nature. This is the torque mgl sin theta. Then you equate it to I alpha, where I is the moment of inertia of this entire system about the point about which the body is hinged. So that becomes this ml square, and you have this very simple formula. This simple formula, this ICM can be written as mk square, where mk square, where k is the radius of gyration. I hope you remember this radius of gyration. So this time period can be written like this: mk square plus ml square divided by mgl. So now it can be written like this. And this can be now written like this, where L equivalent is K square by L plus L. This is known as equivalent length of a simple pendulum. So basically what we have done here is equated a compound pendulum, which is a pendulum of this nature, rigid rod, moving like this, moving like this. It has to be hung vertically. Horizontally, it will not work vertically. You have equated this compound pendulum to a simple pendulum. The length of this simple pendulum, which is not a simple pendulum, if you convert it into a simple pendulum, what will be the length of that simple pendulum? That will be equal to K square by L plus L. Remember, they might ask you this. When it is minimum? It is a question that has come many times. I remember a question coming where they have this, I don't know in which exam, maybe in advance, because it cannot come in mains. Mains is just now. There was this advance, and then advanced question. This is a disk of mass m, radius r, and then they tell you where should I hang this so that the time period is minimum. Time period is minimum when L is equal to K. As simple as that. You have to find the derivative of this thing and equate it to zero, nothing else. L is equal to K is the minimum, and the minimum value is 2 pi root over 2K by G. And this is the graph that you remember. They love graph. JEE people love graph. They love graph. This is the graph that you remember. It is minimum when L. What is L? The distance between the center of mass and the point of projection. This is L. I hope you can see this. I'm going to increase the. Where did it go? The dimensions. How does it come down? It comes down like this. Yes. You see this L. L is the distance between the point of projection and your center of mass. Do we all understand this, or this has gone above our heads? You're not able to comprehend us. I know that I'm moving fast, better, but I'll have to cover a lot of course. That is why I just can't spend more time on this. Do we understand this? Can I have some raised hands that we understand this? No, we don't. Shall I repeat? Okay. Now again, this compound pendulum could be kept in an accelerated frame. Such question has never come. It can come. This compound pendulum could be in an accelerated frame of reference. What difference does it make? Does the length change? No. Does the K change? No. What changes? What will change? Will G, this G becomes your G effective. You just replace G by G effective, and you are done with a new question. So you could have a question like this. For example, I have this rod of length L hanging like this, of mass M, length L hanging like this. And then I put an electric field QE here. Then I put an electric field QE here. And then I ask you, if I move it slightly, what is the time period of oscillation of this SHM? Tell me. Mass is M, length is L. Mass is m, length is L. Mass is m, length is L. When I add QE also, what difference does it make? What difference does it make? I hope you understand the question, right? Don't understand the question, I will draw it again. I have a rod of length L, mass m, hanging vertically. I put it in a electric field. The charge is the force acting on the, let me not call it QE, because QE you will say sir kaise lag raha hai force. I have added a force F onto it, F, and I disturb it slightly. First of all, will this motion be simple harmonic in nature? Is this motion simple harmonic in nature? F is a constant force. Is this motion simple harmonic in nature? Yes or no? For small amplitudes, the amplitude is going to be small. Is this motion going to be simple harmonic? Apply a force like this, or I kept it in an accelerated frame. It is moving with an acceleration A. Yes, this will be simple harmonic, right? What will be the time period of this oscillation? How will you find it out? How will you find out the time period of this oscillation? If it is moving with an acceleration A, give me the answer then. What will be the time period of this oscillation if it is moving with an acceleration A? Answers. Time period will be equal to 2 pi. You have to remember what I have told you, because you might not get enough time to solve this question by that torque and this and that. Anyone? What is the answer when F is applied, and what is the answer if I am in an accelerated frame? So the answer for the first case is k square plus L square. Do we understand this? How did I get this? K square plus L square. Do we remember this? Here. This one here. Here. K square plus L square divided by LG. K square plus L square divided by LG. So I'm straight away using this. Here. So it is K square by L square divided by L multiplied by G effective. Now what is the value of G effective? In the case of A, it is G square plus A square. In the case of F, this A will become F by M ka whole square. Now it looks a completely new problem. Time period of this compound pendulum will be equal to this one. K is the radius of gyration in this case. K square plus L square by L into root over G square plus F by M ka whole square. Again, I can make this problem more complicated by putting this acceleration like this, but I hope you have understood how to solve any question of this type. Remember, this, instead of putting the F like this could be placed in a liquid chamber and it experience an upward force. Same thing. You have to find out the value of G. Do we understand this? It has gone way beyond our comprehension. Please, can I have some raised hand that we understand this, sir? This was a very important point that I had to discuss. But somehow feel that you might have a question this time around on this. Torsional pendulum is out of your course, does not come, so there is no point of wasting any time on this. Do we understand this? Can I have some raised hands that we understand this, sir? Okay. Superposition of two SHMs. Remember, there was a question that we did in the last class, which was on sine square theta and cos square theta and something, something, something. We can have such questions where we have different terms of sine and cos coming together, and then they will ask us whether this motion is SHM or not. These are the questions that are in the fashion today. How you find out? You try to break it up into additions of SHM. For example, if I have two SHMs, x is a1 sine omega t and x is a1 sine omega t plus theta, you can add it by what I call a adding of phasors, phasor diagram, AC, adding of phasors or adding of vectors. You draw the first phasor, which is the lagging phasor, x is equal to a1 sine omega t. Then you draw the next phasor, x is equal to a2 sine omega t plus theta. These are two now vectors. What is the resultant vector? The amplitude of the resultant vector will be a1 square plus a2 square plus 2 times a1 a2 cos theta. And at what angle will this phasor go? This will go at this angle. Let me call this angle as phi. So tan of this phi becomes a2 sine theta upon a1 plus a2 cos theta. Then you can write this phasor r as a sine omega t plus phi, where a is this and phi is this. Do we all know this? Can I have some raise hand that we know this? Even if you don't know it before, now you know it. So I can write it as addition of two phasors. Yes or no? Raise hand gives me more confidence that my voice is getting on the other side of the screen. No, not able to understand this. You have not seen this. You can now remember this. So add two phasors or two waves. These are waves. Two phasors, two waves. In SHM there are also waves. In wave chapter there are also waves. In AC chapter there are also waves. So you can always add these two waves by this fashion. You draw the lagging wave, then you draw the leading wave, then you add them as vectors, and you get here with this answer. Remember it. You have this sheet with you. If theta is 0, amplitude will be a1 plus a2. If theta is pi, they will out of phase, a1 minus a2 or a2 minus a1. Now, this is the most general case that you might find, but there might be other cases. Different frequencies. Now, this is a question for multiple choice. Different frequencies. Then the resultant displacement will be this, and the motion, since the frequencies are different beta, this motion cannot be simple harmonic. Do we understand this? For example, if one motion is a1 sine omega t plus amplitude is same a1 sine 2 omega t, can this be a SHM? What is your answer? What is your answer? Not SHM. The addition cannot be SHM because these two SHM do not have the same frequency. So the resultant is not an SHM. Am I clear? So these were the cases of SHM in the same direction. First case was SHM in the same direction, same frequency. The addition is always a SHM. Second case was same direction but different frequencies. The addition is not an SHM. Third case, a typical case for JEE standards, two perpendicular directions. Oh, what is this? One SHM is happening along X, like this. Chak, 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 chak. One SHM is happening along Y. Chak, 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 chak. Again, there are many cases possible here. They can have the same frequency. They can have different frequencies. We are going to do the simpler of those same frequencies. So the frequencies are same, omega, omega. The phases are different, doesn't matter. Amplitudes are different, doesn't matter. Now again, in this, there are cases. What is case number one? What is case number one? Theta is 0. Their phase difference is 0. Then path will be a straight line. This equation becomes equation of a straight line inclined at an angle of 45, not 45 because A and B are different. If A and B are same, it will be inclined at an angle of 45 degrees, executing SHM, whose amplitude is root over A square plus B square. Please remember these words. This question can directly come in the examination. Do we understand this? Can I have raised hand that we understand this, sir? Angle is 0 or pi. The particle will execute SHM along a straight line. If A and B are same, 45 degrees, amplitude will be root over A square plus B square. Do we understand this? Do we understand this, beta? No? Shall I repeat it again? If two particles or a particle is performing SHM in two directions, one along X, one along Y, and the phase difference between these two is 0 or 180, the resultant path will be path of a straight line. The motion will be simple harmonic and the amplitude will be root over A square plus. If in the angle, phase angle or phase difference is pi by 2, then the equation will look like this. That is the equation of an ellipse. To follow elliptical path. It is performing SHM in two directions, X and Y. Phase difference is pi by 2, 90 degrees. The resultant motion will be motion of an ellipse. So ellipse tells us that some particle is moving in SHM along two perpendicular axes. And the phase difference between those two is 90 degrees. This is another way, one way of understanding what is an ellipse. And if A becomes equal to B, that ellipse, which is a part of a conic section, conic becomes the circle. Now it becomes a circular path. So basically, if something is moving in a circular path, basically it's a superposition of two SHMs along X and Y with a phase difference of pi by 2. We also saw this in the previous class. UCM, uniform circular motion, as a projection of SHM. No, SHM as a projection of UCM. Same thing. Do we understand this? When I have raised hand that we understand this, sir? You don't understand? Raju, Manoj, Ashrik, Vishnu. Great. So far, so good. See, that is what I was telling you. X1 is A1 sine omega t, X2 is A2 sine omega t plus phi. This is how you add them by phasors. So now we'll do one question on this category. Example number 20 and example number 21. I'm waiting for example number 20. Please solve example number 20. Find the amplitude of simple harmonic motion obtained by combining the motion. X1 is equal to 2 sine omega t, X2 is equal to 2 sine omega t plus pi by 3. It cannot get simpler than this one. We'll do question because I think you can definitely have a question based on this. You saw a question in IIT coming on that pattern. So here A1 is 2 and A2 is also 2. Phase difference is pi by 3 or 60 degrees. You get the resultant amplitude A1 square plus A2 square plus 2 times A1 A2 cos theta. The amplitude becomes 3.5 centimeters. Do we understand this? When I have raised hand, that we understand this? Great. That takes us to question number 21. Now, this question number 21 encompasses everything. It asks us what is the amplitude of the resultant SHM, but it is also asking us what is the equation of the SHM. So this will encompass everything. So how will I write it? X1 is 3 sine omega t, X2 is 4 cos omega t. Phase difference is pi by 2, but they are in the same direction. Don't say, sir, this is X and Y. So the particle is executing, two particles are executing, or one particle is executing two SHM in the same direction. What will be the resultant amplitude? So we wrote it in this form. Resultant amplitude is A1 square plus A2 square plus 2 times A1 A2 cos theta. Resultant amplitude becomes 5 tan phi is A2 cos phi upon A1 plus A2 sin phi. So this angle becomes 53 degrees. A1 is here, which is 3. A2 is here, which is 4. The resultant lies somewhere here, R, and this angle becomes 53. So how do I write it? I find the magnitude. Magnitude is 5. It is 5 sine omega t plus 53 degrees. Can I have some reason that we understand this? Now, question number 23 is based on similar, 22 is based on similar concept. Question number 10 is also based on a similar concept. We'll do this question number 24, that is the last one in this category. A particle is subjected to two SHMs in the same direction but having equal amplitudes and equal frequency. The resultant amplitude is equal to the magnitude of individual motion. Find the phase difference. So this question can be asked in vectors. This question can be asked in your AC wala chapter. In any chapter, this question can be asked. So please solve this question. So how to do this? You know the amplitude of both the SHM are same. You call them A and A, and the resultant amplitude is also A. So A becomes root over A square plus 2 times A into cos of delta or phi or theta. From here you can find the value of phi or theta. It is 2 pi by 3 cos theta or theta by 2. You can calculate it anyways and you will get your answer. Am I clear? Shall we move ahead? So Here, what we are going to see is certain simple examples of SHM. These are straightforward questions that you might see in the examination hall. So you can just remember them and mark them. For example, if you have this wire, if you have this wire of mass m and length cross section A and Young modulus Y pulled along the length of the wire, restoring force will be this one. So even this wire, if it is taken as a spring, it will execute simple harmonic motion. What will be the frequency of this simple harmonic motion? You can find out the frequency from this. Basically, you have to find the spring constant K of this wire. And I hope you know the spring constant K of this wire from the chapter properties of matter we should be doing will be equal to YA by L. Do we know this? So this frequency becomes 1 by 2 pi root over YA by ML. Similarly, if you apply this, if you apply shear stress on this wire, shear stress, so this angle theta, you can find out how much will be that shear stress. You can find out the value of that shear stress. And then from there, you can find out what will be the angular acceleration. And from there, you can find out the time period again, T pi m by k. You just replace this k by eta times L, where eta is the modulus of rigidity and L is the distance between the fixed phase and the phase which is applied with the shear stress. You can write out the answer straight away. You can see this question in an examination hall and thank me that you have done this. Motion of a liquid in a V-shaped tube when it is slightly depressed. Same question came in an IIT some years back. It was not V-shaped, it was U-shaped. I think that is the next one. So how you do this? You displace this side by Y, so this side gets increased by Y. So there is a corresponding change in their height. What is the corresponding change in their height? From there you can get the restoring force and your time period will look like this. Draw this diagram. I'll share this PDF with you. Don't worry. I forgot to share this PDF. So I'll send this PDF. All these examples are there. Some worked out examples are there. Solve them. So this will be the time period of this SHM. Again, instead of inclined, you make it vertical and your answer will look like this. Again, partially submerged floating body. If you depress it, what will be the SHM? This is the amplitude, this is the time period of that SHM. Nothing else. This is a partly floating body. Motion of a ball in a bowl. This question has come many a times, different variations of this question. This is best done by the concept of torque or energy, depending on how you look at it. Remember, the time period is 2 pi root over r by g. Motion of a ball in a tunnel through earth, gravitation. This question has come very recently. Remember this. If the tunnel is dug through like this, straight tunnel, then you have a tunnel which is at a distance. I think here, see, this tunnel is at a distance x. Then again, the answer remains same. In case number 1, in case number 2, time period will be same, but maximum velocity will be different. Everything has been explained in this. Everything has been explained in this. I'll send you this sheet. Have a look at this. This conical pendulum thing will again confuse you if this question comes in an examination hall. Remember, this height h is root over L square minus r square, and omega becomes root over g by not L, but L cos theta. So basically, you're looking at the vertical height, not the total length of the pendulum. You're looking at the vertical length of the pendulum. Torsional oscillator, this is not in your course, so you don't have to do this. This is one that you must do: oscillation of a piston in a frictionless chamber. So you have a piston put in a chamber. What will be the time period of oscillation. This is the formula for it. 2 pi root over V by M A square E, where V is the volume of the cylinder, A is the area of the cylinder, M is the mass of the piston, and E is the bulk modulus of the piston. Bulk modulus thermodynamics. We'll come to that. Delta P upon minus of delta V divided by V. For isothermal process, bulk modulus is P. So your answer becomes this. For adiabatic process, it is gamma times P. Remember that velocity of sound Laplace correction, Newton's formula, Laplace correction, and all that. Gamma times P. So remember these two formulae, and you should be okay with this. Now again, a question of this type can come. A ball of mass m is kept at the center of a string of length L, is put to the center in the perpendicular direction and released. Prove that the motion is simple harmonic and find out the time period of oscillation. How will you do this? Just find out the restoring force. Restoring force will be proportional to some sine or cos or tan. For small angles, it will be proportional to theta. Write the value of theta. You will get the proportionality in terms of x. Then you equate it to m into a, and you get the value of a as minus omega squared x. And the answer looks like this. Am I clear? How you have done this? Okay. This is again a simple question. A spring mass system shown in the figure. The spring is compressed by mg by 2k from its natural length, and the block is released from rest. Find the speed of the block when it passes through the point mg by 4k distance from the mean position. I hope such questions can be done easily. So basically, you have to find how much time it takes. You have to find the speed of the block. If you know the value of time, you can put it in the equation for the velocity. This is the equation for velocity, and you can get your answers straight away. Right? Questions of this type, well, you can always try them. If they are hanging vertically, you have to find out the force due to torque created by the weight. Then there will be a restoring force coming from here. Then there will be restoring force coming from here. Then you have to find the total moment of inertia of this entire system. It will just become a bit more extravagant. Look at all these things, it will become just more extravagant because you have to think about this force, the torque of this force, torque of this force. Then you have to find the relation between these two quantities. Then you have to find the moment of inertia of this block and this rod about the point of suspension. This question just becomes too much. Somehow look like this. This is not the time that I can tell you all this, how it is done. So why, what I will say, see, they found the value of xa, xp, just becomes too much. And see, they found out the moment of inertia of the entire system, right? K1, K2, and this question becomes a lot difficult for you to solve. So I would just skip it because there is no point of wasting the time on things that I know would be difficult in an examination hall to attend. Again, question of this nature, floating body, these type of questions you should be able to solve. How you will solve? Again, you take the first equilibrium condition, then you displace it slightly, then you find out the restoring force, then you use the equation number 1, cancel out what is C, cancel out what is from the equation of equilibrium, and then you have already derived this result. I told you that in the first case. You derive this result, you can remember this result, and then you can use it. These are some worked out examples given here. Most of the questions are taken from IITs. The single option one, this is a question from JEE Advanced. Most of the questions are from JEE or JEE Advanced. In this sheet, the year may not be mentioned. See this one, nice question. I'll be sending you this sheet. What you're going to do is, Solve only those questions that are in the sheet, and that is good enough for you to appear in any exam right now. So I'll end up this class with this note. I'll be sending you this sheet, and just try the questions on this sheet. From the next class, we'll be starting with electro, a topic which we'll be spending some time, because that is the topic that is going to get you the maximum marks. Electro and modern physics. That is a topic that is going to get you the most marks. So we'll spend some time there. Then we'll go on to thermo and then we'll go on to thermo. Then we'll go on to optics, and then we'll leave whatever is remaining for the rest of the class. So that's it from my side for today's class. If there's any doubt that you want to ask, you can ask me. Else, it is a wrap from my end. I hope you enjoyed the class. I'll see you tomorrow. Bye bye.